All right. So we got, there's 12 through 19, if you check those out. I think I got some more of them down here. There's a couple more. Some of those we didn't have to do. So check the ones that you know that were on there. Got just like 5 problems tonight again. So we did adding, subtracting, and multiplying yesterday. So today we're gonna add division, but division isn't really thinking as you would normally for division of numbers. It's pretty easy. Actually, we're gonna end up multiplying again by the complex conjugate. So division is in fact really multiplying, but I think you'll see that as we get a little closer to it. So those of you checking your answers up there, is everybody okay? Any questions there? Should have been straight up. I want to get a couple warm-up problems though, before we get too far along with the division. Is everybody good with these problems here? Okay. So if you would, where did I have those problems? I thought I had some up here. Maybe it's one back. Oh, Mr. Grill, where are you? That's fine. We'll just start right here. I'm sorry. I'm just thought I was gonna have some more problems, but let's go ahead and get right to division. Okay, we'll practice those a little bit later. I see where they were, but I messed up. So division is when we have a I in the denominator down here. Okay, as we see now. Anytime we have that, we are going to have to kind of like rationalize it. So if we have a square root in the denominator, we multiply by it, right? Okay, so when we have an I in the denominator, we're gonna find the complex conjugate. So the first thing, we're really gonna end up being more like multiplication, as I had mentioned. So I'm gonna go ahead and put a little bracket around these guys right here. And then I'm gonna put another one here because I'm gonna look at the complex conjugate. So if I have 5i, its conjugate is gonna be minus 5i. And of course, I'm gonna do that to both top and bottom. If I do the same thing on top and bottom, it really doesn't change the answer, it just kind of changes what it looks like. So the bottom line is we're trying to get rid of the I in the denominator. Does that make sense to everybody? So if we take 5i times negative 5i, we're gonna get negative 25i squared. We'll come back to that in a second. Up top, we're gonna get negative 15i, right? And then we're gonna get negative 50i squared. 10i times negative 5i. Let you digest that. That makes sense to you? Okay? So division isn't really like we're dividing, like 10 divided by 5 is 2. You really end up with this process, we really end up gonna multiply by the complex conjugate. Okay? So the complex conjugate is what we're multiplying by. So now we're ready to simplify this. What's I squared? We know I squared is negative 1, so this is gonna become 50 minus 5i. Remember, we always put the real part first there. Make sure we put that real part first. That's why that becomes positive 50. Here is going to become negative 25 times I squared. Well, of course, I squared is negative 1, so that's going to end up being 25. So now we put our complex numbers in standard form, so to speak. Okay, got them up there. And now we've gotten rid of the I. Really, we haven't changed what the answer is. We just changed what it looks like a little bit. Now, there is some commonality here. 50, 15, and 25 all can be, of course, divided by 5. So we're going to clean that up a little bit more by simplifying that. So it's going to be 10 minus 3i over 5. And that's your final answer. Now, in fact, what we have right here and all the way back here they're really equal, okay? They're equal in value. All we've done was, so to speak, gotten rid of the I in the denominator. So division is more like simplifying when it comes to this process. That kind of makes sense. You got to multiply both top and bottom by our complex conjugate, whatever that may be. How we doing there? Everybody okay? Let's try a couple more. Let's start this first one together. Again, the same process. You're gonna do the same thing. I'm gonna put brackets. Because I'm going to need to figure out the complex conjugate. Is the real part first in the denominator? Yes, 4 minus 2i. So its complex conjugate is gonna be what? 4 plus 2i. 4 plus 2i. Now we have some foiling to do. Take a second, foil the bottom, foil the top. Those of you engaging today in the learning process. Foil the top, simplify. Remember, I squared, of course, is -1. We still want to have our real part first. So don't put the imaginary part first. We want that real part first. So we're foiling. I'm going to go with 2 times 4 gives me 8. 2 times plus 2i is going to give me 4i. 8 times 4, 8i is going to give me positive 32i, and then I'm going to end up with positive 16i squared. Complex conjugate. What's good about that is we know we're going to end up with a positive, of course, a whole number. It might not be positive, it could be a whole number. 4 times 4, of course, is 16. That's going to be plus 8i. Then I'm going to get minus 8i. That's cool. Those are going to cancel. And then my final term is -2 times positive 2i. That's going to give me -2. Whoops, not 2 there, Mr. Grubb. What's it going to be? How about 4? -4i squared. So I had the complex conjugate on top and bottom. I go ahead and FOIL that on out. Now we're ready to simplify this guy. Okay? Now what's nice is what happens. What happens to these right here? Cancel, don't they? What does this become? None other than positive 4 now, doesn't it? Because we have the I squared and -4, so it's going to be positive 4. So my bottom ends up being 20. What does this become right here? It becomes -16, doesn't it? So we're going to end up with -16 and 8, so that's going to give me -8. Remember, we put the real part first. My imaginary part are 4 and 32, which would be plus 36i. Now, just like the previous problem, we have some commonality, don't we? What number can go into all those? 2 can go in and also 4. So let's put 4 in there. We're going to end up with -2, right? Plus 9i over 5. And there it is. Your simplified answer. Everybody good? Okay, that was one with a complex conjugate. The second one over here, okay? Same process. Complex conjugate is going to be different. What's going to be our complex conjugate of -i? It's just going to be positive I, isn't it? Go ahead and see if you can work a little magic on that one and simplify it on out. You guys are awesome. You're staying engaged. I appreciate it. So we're putting into play that I squared, of course, I squared is that -1. Again, make sure you put things in the proper order that they need to be. So let's go ahead and we'll take this, gonna give me 3i plus 8i squared. I'm just distributing here. This is a little tricky one. I'm gonna get negative I squared. You gotta watch that one. Now we're ready to simplify. Now the negative I squared, what do you think? It is 1. Negative I squared. Remember, that'd be -1 times -1 basically, because I squared is -1. Okay? That ends up being 1. Of course, plus 8i squared becomes -8. And then we're just gonna have the 3i. Remember, we always gotta put that real part first. -8 plus 3i. And most of the time, we won't put this 1 underneath here because it's not, not really necessary. So, you're gonna end up with that guy right there. -8 plus 3i. So in fact, division is really what? Multiplication, isn't it? And what are we multiplying by every time? The complex conjugate. And we got those down. It's just kind of like the opposite of what we were looking at. How are we feeling? Okay? Let's, just for a little review, let's see if we can knock these 5 problems out. We'll start with adding, number 1. Then number 2 is subtracting. Number 3 is a little FOIL in action. Number 4, I to a power. Remember, those are sets of 4. And then what we just did today. So I'm just asking you to engage a little bit, do a little practice on these, give you a little head start. I'll do number 1 here in about 40 seconds. Make sure you know what you're doing, and then you can move on to number 2. Don't need to wait for me to get you to number 1 and 2. You can move on. So remember, on adding, we're just gonna put the like stuff together. So we're gonna have 2 and -6 gives me -4, keeping the real part first. And then we're gonna have 4i minus 4i, so guess what? Those end up canceling, so -4 is all we end up with that first time, isn't it? Now on that second one, make sure you distribute that negative. It's gonna change a few things there. It's a natural light. So it does help sometimes if you want to write it out. It might be helpful for you. Okay, so we're going to have 5 minus I, distributing -8 plus 2i. So we have 5 minus 8 gives us -3 for our real part, and it's going to give us plus I for our complex part. I'm not saying you have to do it that way, but it probably is best to keep it, that way you know what you're doing with your negatives and positives there. All right, foiling up. They're not complex conjugates. So we have some foiling to do and combine like things. Those of you still hanging in there, give you a little second on that one yet. So we'll distribute 2 times 3, it's gonna give us 6, of course, and then 2 times -2i will give us -4i. We're looking at positive 15i, and then we're looking at minus 10i squared. Minus 10i squared, of course, gets us to be 10, positive 10, and 6 gets us 16. And then we're gonna have plus 11i. Pretty sure I got that right. I don't know why it feels wrong. Is that good? Is that what it was, everybody? Right. I to the 31st power. Remember, we're looking at every sets of 4. What's the closest multiple right under 31 of 4? Multiples of 4. 28, right? So basically, I can take 28 of those i's away, and I end up with I to the 3rd, which is negative I. Okay, we're down to that last one now, 5. Those of you hanging in there, start with brackets. Complex conjugate, 1 minus I, so the conjugate is going to be 1 plus I. So now you got some FOILing and some simplifying to do. See how far you can get there? Good stuff today. Thank you for everybody. Let's see. We're going to get 4 times 1 will give me 4, and it's going to give me plus 4i. 4 times 1, 4 times I. It's going to give me minus 2i, and I'm going to get minus 2i squared on top. Now, if you start to get pretty good with these, you know the complex conjugates, you really only have to do part of it because the other parts cancel, don't they? So I'm just going to take 1 times 1, which would be 1. Then I'm going to have negative I squared because the other parts are going to cancel. If you don't see that, you can go ahead and FOIL it all out. That's a little tricky. 1 minus I squared. Anybody? 1 minus I squared is really what? Ends up being 1 plus 1, which is 2. Seems a little bit crazy. Okay, remember negative I squared would be like negative 1 times negative 1. So we end up with 1 plus 1, which is 2. This ends up being positive 2 right here, doesn't it? So we're going to end up with 6. And then we end up with 4i minus 2 would give us plus 2i. Ah! Have some commonality here, don't we? What can go into all those? Of course, 2. So this whole thing ends up being 3 plus I. Kind of unique. 3 plus I. Of course, we don't write it over 1. Okay, is everybody okay with where we just got that down to 3 plus I?
Does it matter if we write 100, like, would we lose points for that?
If you what?
If we write like 100, would,
No, you won't lose it. No, that's fine. Not a problem. Any questions? Okay, so really division is more like really what? Multiplying, isn't it? And what are we always multiplying? Complex conjugate. All right, just a couple of problems tonight, 30 to 35, nothing worth shattering. You can submit that online, of course. Tomorrow we'll start a practice assessment in class. I have it on Canvas already. If you want to look at it, it's fine, but you'll have class time tomorrow to work on it, okay? So Monday we'll review a little bit more. Tuesday will be the assessment on chapter 5, complete chapter 5.